Yes, today is lesson 5. Actually, the way I've given you, it was only lesson 4. Since we did not finish our application there, we are still continuing. That keeps happening, don't worry. Now, application of sum of two vectors in physics, this only is continuing. Resultant of two forces, resultant motion. So, okay, that we are continuing. We are one lesson behind because we are going slow. Okay. Yes. Forces thing we did. Momentum will do. Say there are 3 particles. Let me say all of them have the same mass. M, M, M. Now they move towards the center of the triangle. There's an equilateral triangle, children. They move towards the center of an equilateral triangle with speeds v each. They might collide there, something will happen, don't worry about it. My question is not connect with the collisions, not what after collisions. My question is about what is before collision only. So total momentum of the system of particles. Before they collide, like this. So I'm only asking you to add the momentum and tell me. So momentum formula, you know, don't you? P equals mv, or p bar equals mv bar. Momentum is a vector quantity, mass into velocity. So P of the system will be simply what? mv plus mv plus mv, that is 3 mv. Is it right?
Yes.
Damodar, why are you not coming every day to the class on time? Right. Is my answer correct, children?
Yes.
Hello. No. Because you cannot add momenta like numbers here, because they've got directions like that. Isn't it? If all the 3 particles had momentum this way, then you could add mv plus mv, 2 mv plus mv, 3 mv, you can do that. Tell me.
Yes, sir.
So that's not correct.
Sir, why can't we do like that, sir?
Tell me, why can't you do like that? Because momenta are vectors. Tell me, Guru Charan. Who was talking previously? Guru Charan?
Yes, sir.
Who was saying, why should you act like that?
Sir,
Why should Enoch?
Yes, sir.
So what lesson are we doing?
Scalar
Vectors.
Yes, sir.
right? So if I have number 2, another number 2, another number 2, 2 marbles plus 2 marbles plus 2 marbles, how many marbles? I can say 6 marbles.
Yes, sir.
The whole idea of doing vectors is that, no? Why do we have the law of parallelogram vectors and law of triangular vectors,
Okay.
Tell me,
To find that sum.
find the sum. If you can add like this, why actually one law like that? Tell me. Momenta are vectors.
Yes, sir.
So when you add momentum, you need to consider the directions also.
Okay.
Do you follow?
Yes, sir.
So you cannot add mv plus mv like this. Do you follow?
Yes, sir.
So that is not correct. We need to follow. Of course, you could write the mathematics like this. P bar equals, you can say P1 bar plus, sorry, P2 bar or vector P2, vector P3 you can say, but it is still not adding. It is only telling that you have to add vectorially. That's all.
Yes, sir.
It doesn't tell you how much is this. It only represents that sum of vector sum of P1, P2, P3 is P. How much is it and what is the direction of it? We need to follow what? Cosine rule.
Yes.
So why that question came up, the reason I'll tell you. There is, today's lesson is not independent lesson. Tomorrow's lesson is not another independent lesson. Day after tomorrow's lesson is not another independent lesson. They're all connected. Do you follow? So why am I saying like this? Anytime, remember, we are teaching a story from A to Z, not A is different from B, B is different from C. So the whole lesson is about what, Enoch? Vectors, basically.
Yes,
Scalars anyway are simple to deal with. So to add vectors, we have geometrical rules, different geometrical rules, algebraic equations. Isn't it so?
Yes, sir.
And that fellow Vignesh, you know why I cannot say 3MV?
Yes, sir, understood.
And in the example, when I mentioned 2 momenta are in opposite direction, one is some numbers I've given you, this total momentum is 0, I told you, So how can you immediately forget so an important idea? Right. Now, how to do that? I've got 3 vectors, but I know how to add 2 vectors only until now. Okay. I'll call this as P1, this as P2, this as my P3. Right. Look, their magnitudes are same, but they're different vectors. That's why they are given different names, P1, P2, P3. Let me add 2 of them first. Let me move P1 like this, P2 like this. Vectors can move parallel. This is moved this way, this is moved this way, so that the tails join. So I'll get one parallelogram, isn't it? So the resultant of this P1 and P2, I should find out. What is this angle, children? This angle. Is it 120, 120, 120 like that?
Yes, sir.
Because this whole thing is 60, this whole thing is 60. So this is 30, 30, 30, 60, 120. So angle between them is 120. Now the resultant is like this. You already proved previously. You can directly write it if you want. This is mv, some x, then magnitude. Magnitude of this is x. The angle is 120. The resultant is also x, right? Did you see that previously? No, now I understand. You're just only following that particular question and the logic. And when that comes back again, mind is retrieving it. But connections are
Yes,
not
sir.
made.
You gave a question yesterday.
So relationships between the question and question is going away. That's not correct. That's not the way to study. Enough. You're looking at every question separately. Otherwise, I should do it all over again. What's the point? I'll do it. P1 square plus P2 square plus 2P1 P2 cos 120 under root is equal to resultant R. P1 is x square plus 2x square cos 120 is minus half. So did we do this already or not?
Yes, sir.
Then,
Hmm.
so now this is x. Now the third one is also x in the opposite direction, isn't it? So the resultant is 0. So resultant, and you can do it for these two and show that sum of these two is equal and opposite to the third one. You can do these two and show that sum of these two is equal and opposite to the third one. Whichever way you do, finally the total momentum will be 0. It's not 3 MV. Amarnath, what was happening?
Sir, can you tell how we got 120 degrees again?
120 degrees again. What do you mean 120 again?
We got 120 degrees. Can you explain how did you get 120 degrees, sir?
What is the angle? Equilateral triangle. What is the angle here and here and here?
60.
60. Now this is the angular bisector, this one. So how much is this?
30.
How much is this?
30.
Then how much is this?
20, sir.
Huh?
120.
Why? Because 120 plus 30 plus 30, 180.
Yes, sir.
Similarly here also. Similarly there also. Tell me.
Yes, sir.
Then after that, others. Children.
Clear, sir.
Yes, sir.
Now, but yes, all saying S in chorus. Good. Now, have you really understood? I did not show it again. This third one is equal and opposite to this. Did you follow that point?
Yes, sir.
And
180 degree.
resultant is mod A minus mod B. So x minus x. 0. So whenever you get something like this, remember the sum will be 0. That means there are 3 vectors, not only momenta, just any 3 vectors. They have got 120 degrees between each pair. The net will become 0 because sum of any 2 is equal and opposite to the third. In one of the problems you answered it when there are 10 newtons, 10 newtons, 10 newtons. This I discussed already, no? Why? Because of 1 or 2 days gap, you forgot everything. 10 and 10 resultant is minimum 0, maximum 20. The third can be producing a 0 resultant with this we told you, know how? If 10 and 10 are acting at 120, the resultant is 10 again. This 10 can be opposite to this 10. That will happen in this case, for example. So Enoch, tell me, MV plus MV plus C, 3MV is wrong and this is 0 is correct. Do you follow now?
Yes, sir.
Can you tell how did you follow? What did you follow? No, actually, if you speak, I'll be knowing your minds. Because that can be a very simple question like Manasa was asking. How is the angle 120? No problem in the beginning. That's elementary, actually speaking. But there is something more here. Like When we add vectors, it is not looking like scalar addition. Vignesh,
Yes, sir.
why 3MV is wrong and why this 0 is correct? Can you tell in your own words now?
Yeah, sir. Because if it's not 3 MV because momentum is not a scalar quantity, sir, and has a direction to it.
Yes.
Plus, it's not necessarily 3 MV. It can be anything.
Yeah, not necessarily. It won't be 3MV unless they're all in the
Same direction.
same direction. Only that case it will be 3MV. In any other case, it will be something else.
Yes, sir.
And here they are arranged in such a way that the sum is 0.
Yes, sir.
So that is the difference between vectors and scalars. So when I asked you that, sir, it is after all, see, it's not, they are not scalar, they are vectors. So when I'm adding, I'm also what you call adding along with their directions, not just the numbers. Isn't it?
Yes, sir.
Look, intuitively also, when these two are there, the sum looks like to be up, no? This is like this is like this. So sum will be like that. And the other one, third is opposite to it. Isn't it so? Okay, now to check whether you follow it or not, I'll ask you another question just before 1 second. Now I'll give a similar question to know whether you understood it. And not only doing it, but I want you to speak also. Because look, your life, my life become meaningful later. Because now I'll think that you're following later when we try to do better things. If you did not follow now, when the things get tough, we become pressurized. Okay, now I'll give the same question slightly different way. Let me see. Once again, an equilateral triangle only. Okay, once again, I've got mass M here, mass M here, mass M here. But one thing is different. This is going with V. This is coming down with 2V. This is also going with V towards the center. So what is the momentum before they collide? What is the momentum of the system of particles? Momentum of the system of particles. System of particles before they collide. Come on.
Sir, is it V?
First
Yes,
of all, momentum cannot be V.
MV, sir.
MV. Vishnuvardhan says MV. So others? And in what direction, Vishnuvardhan?
Downward directions.
Downward. That means this fellow followed. At least the logic he followed.
Sir? Sir, the answer is MV in the downward direction.
Yeah. Now I would like to know, did you catch only the mathematical logic, also the meaning? Because you do today, tomorrow you're forgetting. That's where I'm really worried. Vishnu. This is MV, this is MV, like that we move them parallel so that they make an angle like this. You know, this is moved there, this moved there. So the resultant is already we proved to be what? MV. Because angle is 120. Now that is 2MV, right?
Yes, sir.
So 2MV and MV are opposite. So it will be MV downwards because 2MV
Yes, sir.
minus MV. See, we are minus here, we're subtracting, but remember, this is not subtraction, it is vector addition.
Yes, sir. Addition of vector.
Vector addition, this is not vector subtraction.
That
Vector
one
addition,
needed.
vector addition is giving MV downwards. That is
Yes.
mod of A plus B will be mod A minus mod B when the angle is, tell me,
120.
180 degrees.
180 degrees. Angle between 2MV and MV is 180 here. They're opposite, right?
Okay, yes.
You're catching the superficial patterns, not the deeper patterns. All right. And the second sum is given only to make the meaning of the old sum even more clearer. Do you follow?
Yes, sir.
Yes, sir.
Right. Then so can I continue? Because I have to go to something more interesting.
Yes, sir.
No, actually there were all so many problems, children. Before I give an assignment, I have to give assignment after doing a little more. I wanted to keep doing the same questions again so that like this today you forgot many things. That should not happen. So if I make it this way, okay, let me see. I'll just give the same thing slightly once again. I'll change. I don't want to do more of this. You just tell me the answer directly. We've got mass ME here. It is going with 2V. Here I've got a mass 2M. It is going with V. All are going towards center. So what is the P system now?
MV.
Huh?
MV.
Which direction?
Sir, MV
Downward
is
direction.
upward direction.
Yeah,
Huh?
upward direction. Upward direction. Sir.
Sir, I think MV in the direction opposite to the left down.
That's correct. Now you move this down, move this way. Move this 2MV down. This is 2MV. Move it that way. Right? This is 2MV. This angle is 120. So resultant is 2MV again. And this MV is opposite to it. Right? So it is towards this and MV. Do you follow that? Vishnuvardhan, Vignesh.
Yes,
Hello, children.
Understood, sir.
Okay. I'll continue, children. Actually, there are other ways of proving this later, but I just ask you to use law of parallelogram vectors geometrically and the cosine rule put together. That gives a better meaning for these things. All right. Okay. So I've given you one formula directly, which I'm not deriving now. I'll be deriving it later after teaching something more, but I use the word resultant motion there. Resultant motion. What it means, I've already told you, but I'll just repeat it again. I'll be using the correct technical words. If I use loose words, you may think that you are following it, but that will be not useful later. I'll use technical words here, not the regular words used by teachers in the classes. What are the regular words used? I'll tell you first. And they look actually easy, but they're not correct and they don't see you through difficult times. I'll tell you. There is a bus. Okay. Or the compartment of a train. It is easy to say this bus is going with 10 meters per second. There's a person running on it with 2 meters per second. So his net velocity is 8 meters per second. This way you can say. This is very easy to listen. And if the person is running like this on the bus with 2 meters per second, his total velocity is 12 meters per second. This way you might say total velocity, net velocity. You might say so many words, but that's not useful because there's nothing like some 10 number here, 2 number here, opposite you subtract, same direction you add. That's okay. That's a very superficial level of logic in physics. We should give names for these velocities and generalize them. This 10 meters per second will be called what? Velocity of the bus. Tell me, velocity of the bus
with respect to ground.
with respect to ground. Otherwise, it's meaningless. Do you know? Because you must have heard these words many times. Rest and motion are relative terms, you say. Did you hear these words anytime? Rest and motion have meaning only with respect to a particular surrounding. They don't have an absolute meaning. Can I say that I am at rest?
Yes,
Can you say that I am at rest, though I am sitting in front of you? Can you say that I am at rest? You cannot. But you can say that with respect to ground, you are at rest. With respect to, say, for example, moon, I am in motion along with the earth. That's the meaning of saying that rest and motion are not absolute terms and they don't have a unique meaning. They have a meaning with respect to the reference frame or with respect to surroundings. What do you say? When you're going in a magnetic levitation train, for example, which doesn't give any sound, tuck tuck like that, and all the curtains are drawn, windows curtains are drawn, you're sitting inside, you watch your fellow passenger in front of you. You'll say that the fellow passenger is at rest, but somebody watching from outside will say that you are in motion. And that is what you feel in an aeroplane, right? Though that will be going with so much speed with respect to somebody on the ground, you look around, you are at rest only, unless you see through the windows, for example, unless you see clouds outside passing by, you cannot say that you are in motion, isn't it? Hello.
Yes, sir.
So just saying that somebody has a velocity, bus has 10, person has 2, so the net velocity 8, net velocity 12 is all very, very loose way of talking physics. Do you follow? So
Yes,
velocity of the bus with respect to ground is 10. And what is this 2?
velocity of person with respect to bus.
Velocity of
Person with respect to bus.
velocity of person with respect to bus. That's correct. Other people, you need to keep talking. Otherwise, I have to go for a still lesser kind of a talk. So this is velocity of the person with respect to bus. And then what is this 8 or 10, 12? This is A, my observer here. This is B. So what is this 8 or 10?
So it's velocity of person B with respect to A.
That's correct. So velocity of person B with respect to A is 12 meters per second. If this 2 is this way, if 2 is that way, velocity of B with respect to A will be what?
8 meters per second.
So 2 fellows responded. How about others? Manasas. That means, I mean, girls and boys. But can we only say that like this only opposite direction, same direction? Do we have only those two cases? Ignesh?
No, sir.
No, there can be as many cases as possible, isn't it? Like my point is this, the bus is going like this with 10 meters per second. The person may be going like this along the breadth of the bus with 2 meters per second. So what is the velocity of this person with respect to somebody on the ground? Vector sum of these two now you should take. This is 10, this is 2. So for him, the person appears to be going like that with
Under root
Root
104.
104.
Hope you followed. Gurucharan, Vignesh, and Vishnuvardhan seem to have followed something. How about Shivacharan and others?
Yes, sir.
Yes, sir.
Can I push a little harder?
Yes, sir.
Okay. Now you could catch the logic, but what does it mean to say velocity with respect to bus? Who will feel it?
The passengers in the bus.
No, passenger bus have to look upwards. But anyway, what he means to say is this: somebody is standing here, not the person walking. The person walking is the one to be studied and applied physics to. This is the person walking. So this fellow, what you call, fixed to the bus. For him, bus will be at rest, children. Unless he sees outside trees moving past, for him the bus will be at rest. So he says that this fellow, this is we said A, B we said no, this is another fellow C. So C will say that B is going breadthwise with 2. And A will be saying that bus is going with 10. So for me, B will be going like this. So that's what I mean by pushing a little harder. Do you understand what I speak?
Yes, sir.
Look, this is the direction in which this fellow C goes. See, we call him C, B. B goes like this for a person standing on the bus, who is C. And the person standing on the ground says the bus is moving this way and B is moving this way. So for A, B moves this way. For C, B moves this way. Is it okay, reasonable to you?
Yes, sir.
So this is what I meant by making it very general. See why the word resultant motion, we are saying that this is the resultant motion. The motion of this person as watched from ground. So this only we put in more vectorial terms. Can I continue, children?
Yes, sir.
I'm continuing, but you can keep talking to me. Look, so that's what we wrote. Velocity of, but we need to include all the cases, opposite, along the same direction, perpendicular, but between 0 and 180, there are so many angles. I cannot simply say, now you subtract, now you add up and keep only those few cases in the mind. I have to make it very general so that can become 100 cases. So I should write like this: velocity of a body with respect to, this way I'll write, velocity of a body with respect to what? Shall I say ground to make it simple? Is equal to, tell me, velocity of the body with respect to bus, river, what?
Bus.
Moving frame. It can be bus, it can be river, it can be many things, aeroplane. So why should you write only bus? Bus is the moving frame now.
Yes.
Plus velocity of the
Moving frame
with respect to
ground.
Yes. So this is what the resultant motion is. That is, this is called resultant motion. resulting
Sir, what
velocity.
if the bus is moving with 10 meter per second and the person on it jumps,
Gems where?
jumps and lands again on the bus?
You tell me gems.
He'll jump just at an instant.
Are you ready to if I discuss it? I don't know. Look, he's asking a question. I don't want to disappoint him, but others should not get worried. What this fellow says is this. Bus was going with 10. Huh? This person doesn't move like that. He jumps, he says. So Guru Charan, while jumping, what kind of velocity has got? You tell me. Now, with respect to the bus, how is he jumping? Is he jumping vertically?
Yes, sir.
Vertically, for example, with what velocity initially? The initial velocity with which he hits the bus and moves is how much? For example, you take a chance, 2 meters per second. Very high. You won't do that, but anyway. Now, for you, he doesn't jump vertically, Guru Charan. He jumps like this with 10 square plus 2 square.
Sir, when he'll jump, the bus will go forward, no, sir.
That's why I'm telling you. When this person was there, he had this velocity also, no, along with the bus.
Yes, sir.
So he's pulled forward and he's also pulled upward. So net he'll be pulled like this. Pull means
Okay,
he'll push himself up like that. It's both intuition plus maths. That's what is required now. So
yes.
this 2 meters per second is what velocity relative to the bus. This velocity is what velocity of bus. So velocity of this person with respect to ground is vector sum of these two.
Okay, sir. Yes.
Tell me, children. Okay, I'll extend this for a while because Guru Charan anyway mentioned it. I'll go a little physics way today. No problem. We can wait to give the applications. Now, this is going with a constant 10 like this. Here I showed only 10 at this instant, but let me say it is all going with a 10 only. There's a person here throwing the ball up. Will he catch the ball? First of all, and where does he catch? How does he catch? All that I want to know. Once again, the same idea. Whatever we put only will come here. I'm standing on a bus, or you can sit in the bus, doesn't matter. Not necessarily that you should stand on the bus all the time. I'll say, I just wanted to extend because Guru Charan was saying something. Let me tell you, it's an interesting one. This is all the time going with 10 meters per second. I'll throw a ball up like this. So first of all, this fellow's name is B. Will B be able to catch the ball?
Yes.
Sir, sir, is B on top of the bus or inside the bus?
Inside the bus.
He'll catch it, sir.
He'll catch it,
He
sir.
can, sir.
Yes.
He
sir.
can, sir.
Are you telling it with what you learned somewhere, or can you really elaborate that?
Yeah, normally we can do in any.
Sir,
Sit in any.
sir, if B is inside the bus, sir, then
Yeah.
if he throws the ball up, as he's stationary with respect to the ball will just come back to him, sir. But if he's on top of the bus, he will move forward and the ball will go behind, sir. So he won't be able to.
No, nothing with top and bottom. He'll be firmly rooted. What matters is the constant velocity here. There's nothing differentiates between the top and bottom. Only thing is that air anyway we ignore. The air resistance, all that, ignore it. Okay. So motion is only under gravity.
Sir, so since the horizontal velocity of both the person and the ball is the same, he'll be able to catch the ball.
That's correct statement, because I already mentioned it there.
Yes.
So though it leaves the hand, see, when the ball was in the hand of the person, this has the same 10 meters per second, no? Huh? Come on, the
Yes, sir.
ball had
Yes,
the
sir.
velocity of the bus because he was a part of the bus.
Yes,
So the
sir.
ball had two velocities. One is 10, the other is 2. So where is the net velocity? Like this. Huh? Hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
Now, look, when the person catches, if I'm watching from here, the person is no more here. He'll come here. And the ball moves on a parabolic path, and then fellow will catch it. This is my observation. But the fellow inside thinks it's going up and coming down. That's all. All this is understood from here. That's why I'm telling you. When I watch from outside, this is some A, we said, no? He will catch the ball, but how? B won't be anymore here. He will be somewhere here. The bus would have moved like this, isn't it?
Yes,
Hello.
sir.
So the person any more won't be here. He will be somewhere there, and the ball will come and fall into his hand. So I'll say that once a person release the ball, it will follow a parabolic path, and then person will move forward and catch it. Move forward means don't run, but he will be moving along with the bus for us. Do you follow? Whereas the fellow inside says it's going up and coming down. That means the ball will be going up in a vertical direction, coming down in a vertical direction. He catches it. That's the feeling of B. But A says no. B will catch it somewhere there. Tell me whether you followed it.
Understood.
Most important thing. This from here, when Newton, Galileo, they gave great principles in the beginning. Come on,
Understood, sir.
Vignesh, really?
Yes, sir.
Really? Can you explain it now? Now the resultant velocity is looked from where?
So with respect to A, sir.
With respect to A only, because with respect to B, this velocity of the bus won't be there, right?
Yeah, sir.
Because he is a part of the bus, right?
Yes, sir.
So bus moves with 10, he moves with 10. So there's no change of position of B with respect to the bus.
Yes, sir.
This is a very common sense feeling. Have you all, anytime went in an aeroplane? Anybody at least? One of you went. Is it not boring in a plane?
Yes, sir.
Why? You
You
don't
have
seem
to
to
put seat
be
belts.
moving only. That's the best example of what you call inertial frame. If it is not accelerating, you will know the plane is moving only in two ways. One is you look through the small window and your clouds are going behind. If you are going through clouds, nearer clouds, or sometimes there will be, what is that? If it is rough weather,
Turbulence.
turbulence, yes. Then you'll know that something is happening. But otherwise, you sit like this. If you're traveling 12 hours, you really get bored unless you watch some movie on the screen there or do something. And with how much velocity must be going for somebody watching from outside? High velocity, right? Huh?
Yes, sir.
Yes, sir.
So, and in that uniformly moving train, you throw a ball up. What will happen? It goes and comes back. It falling into your hand is true for you and for a person outside. Don't say he'll catch it in the what you call with respect to the plane, and he doesn't catch it with respect to outside. You cannot say, because catching is a real thing, right? Hello, the ball
Yes, sir.
touching the hands, the person is real. It cannot change by changing reference frames, but your explanation will be different. So your explanation from ground frame will be what? The ball will leave the hand. Once it leaves the hand, it has got even the this
Velocity of
because
the
he
ball.
gave it an extra velocity like this velocity is there, this velocity is there. So ball will be actually going like this under gravity. So it will follow this path. But this person also has the same 10 meters per second, no? So this 10 meters per second is not going to be affected by gravity. Only the 2 meters will be affected by gravity because gravity is down. So he will go with 10, ball will go with 10 same direction, right? So this B will be here when he catches the ball. That's all our understanding, whereas he doesn't know that he's moving far. So for him, it goes and comes back. For A, it is having two velocities. What? This velocity and this velocity. Whereas for B, it has got only this velocity. So what is resultant motion now? What is resultant velocity now? It is a velocity as watched from ground frame or fixed frame, to make it even more general. That is the resultant of what? Velocity relative to the moving frame. This 2 meters per second is relative to the moving frame. Remember it. Only this fellow says that I'm throwing it up. This fellow doesn't say he's throwing it up. He'll say he's throwing it like this only, right? Hello.
Yes, sir.
So velocity with respect to ground frame is the vector sum of what? Velocity relative to the moving frame plus velocity of moving frame with respect to ground frame. So this is very relative. So
Sir,
tell me.
this bus and
I'll give another
One.
example. I'll give another example, children. Look at this. Now, after understanding, it's just a matter of time that you finish questions. I have a river. River banks are shown here. This is a flowing river. Okay. Now, I've got a swimmer in this. He would like to cross from here, from this bank to that bank. This is bank 1, bank 2. The river has a velocity. How much it may be?
10 meters per second.
Oh, 10 meters per second will be very high. Unless it is
2 meters per
3
second.
5
meters per
kilometer
second.
per hour.
So 2 kilometers per hour we can put a slow moving river, for example. River. So who is saying this Mokshagnya? Who says river is going with 2?
Person on the bank.
Like somebody standing here can say that. Can a person moving in a raft, this is a raft, I'll say, float, raft, wooden piece. For him, rivers will, waters will be at rest or will be moving.
Shall we address, sir?
It's a rest.
You understand?
Rest.
Yes, sir.
Okay. So that you understood. There's a person called A here, there's a person called B there. Both are watching a swimmer here. Okay. Hello, children.
Yes, sir.
Yes, sir.
Let me say this is 4 kilometers per hour. Now, this fellow swims with 2 kilometers per hour with respect to B. That means for B, waters are like pond, P-O-N-D. And this fellow swimmer, this person, swimmer, I will call him C. C is moving with 2 kilometers per hour with respect to water. And for A, waters are moving with 4 kilometers per hour. So for A, swimmer will have what velocity?
6 kilometers per hour.
6
yes.
kilometers per hour.
These numbers you're catching, but the generalization you're not catching, I think. When I'm giving numbers, you're immediately giving the answer. Why should you generalize it? Because I want to apply it for various cases, not just they're in the same direction or opposite direction or 90 degrees. That's what I want. So now, what is this velocity called, children? In general,
Velocity of swimmer with respect to river.
Right, swimmer with respect to river. But only swimmer and river should be applied. So I should make it general. What is that? Velocity. What?
Of moving object.
Velocity of the object body with respect to moving
Motion.
frame.
moving
Fixed frame.
Moving frame, you should say. Or simply we can say it V relative. Very simply we can say it V relative. The word relative is with respect to a moving body, you think that's life is easy. Or for the case of reverse, people call it velocity in still waters. I don't want to confuse you more by giving more names, but people keep using this. Why am I saying velocity of person in still waters? You know, for B, waters will be still only. Not that for A, they will be still. You understand? So for B, these waters appear to be still. So for that fellow, pond, I told you know, this pond waters are still. So B says in still waters is going with 2 km/h. Waters are not still. Waters are actually moving with respect to this fellow. But don't get a wrong impression. This is only a feeling. What he sees is the actual velocity is 6. Don't say. Many teachers say, see, river is going with 4, person is going with 2. The actual velocity, total velocity is 6. Those words I'm not using. Do you follow? Because there's nothing like actual velocity. A is correct that he's going with 6. B is correct that he's going with 2. Both are correct. So there's no actual velocity. Do you follow?
Yes, sir.
Now, and what is this 4 km/h in general called? Velocity of moving frame.
Moving frame.
And what is the velocity of C with respect to this one? Velocity with respect to shore, we can say here. Velocity of the person or swimmer with respect to shore is here. But in general, I can call it what? V with respect to what? Ground frame. Or I can also call it V resultant. I can also call it V with respect to fixed frame. So many names I can give to this. So if I succeed in making you understand the meaning of it, then my life is easy tomorrow.
Sir, what is the velocity of river with respect to sea?
With respect to
Sea.
look, in physics, actually, don't make the body as the observer. This is the body to be, it will be 0. But in that case, he should watch somebody else. Do you understand my point?
Yes,
Guru.
sir.
Here, this is the body to be studied. Body to be studied means what? On him, you apply physics laws. So this is the body to be observed. These are the two observers. B is an observer. A is an observer. You understand? So
Yes, sir.
if you want to make him observer, whom is he watching, he should talk. Otherwise, just saying that velocity of the river with respect to me 0 doesn't make any sense. Do you follow?
Yes.
Right. Any other question, children? Others should speak, because in the beginning itself, I take few risks with children, because that actually makes things easier later. Children, this terminology is all right for you?
Yes, sir.
Yes, sir.
Yes, sir.
Really? Enoch, Vishnu,
Yes, sir. Yes.
and today,
Yes, sir.
Amarnath, you came in today, right?
Yes, sir.
Tell me, did you follow something?
Yes, sir.
I want you to read listen to all those 4 lessons of vectors. Huh?
Okay, sir.
And you make few notes and send them to my WhatsApp. Let me see how you understood things. Huh?
Okay, sir. Okay, sir.
And you can also speak in Telugu if you feel you're not comfortable with English. There's no problem. Hindi, Telugu, English, 3 will go.
Okay,
Huh?
sir.
But
Okay.
because physics actually doesn't require serious English, actually, though you require English when you want to talk in a proper way, you require. But in spite of it, in the beginning, there's no problem. The ideas, whether you could catch the idea, whether you understood the what you call this kind of notation, all this is important. Huh? So I can write like this, no? Velocity of a body in fixed frame. Huh? Hello.
Sir.
Velocity of a body in fixed frame means what here? that is not going to move. It's rest. The ground is equal to velocity relative. Relative means I can drop the other subscripts, velocity of the body with respect to the moving frame, plus velocity of moving frame with respect to fixed frame. This I'll show it even analytically. I'll prove it. I'll get this, derive the formula from the geometry, basically. Tell me, children. Hello?
Yes, sir.
Yes, other girls, you did not speak. Okay. We shall continue tomorrow. Remember, there will be very, very interesting questions on this. But I'm taking my time to make you understand the terminology. Okay. I'll be closing it for now. Tomorrow we shall meet again. Unless and until I change the ID and password, the same password will continue, Vignesh. Okay. I'll
Yes,
change it.
sir.
Okay. If I change it, I'll send it to you in advance. Otherwise, the same. This is my personal ID. Sometimes I keep changing, sometimes I don't. Okay. All right. I'm ending the show for now.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you so much. We'll
Thank you, sir.
come back tomorrow.
Yes, sir.